So, welcome back, guys. In this segment, we will cover question 3 and 4 from Part C data processing for complaint analytics. These questions focus on two important topics: smoothing extracted scores, schema integration, and resolving value conflicts. So, let's begin with question 3 solution, which is hold on. Yeah, here we go. So, we are given a list of severity or evidence strength scores. After sorting the list, we get this, where total number of values are 12. We apply smoothing, which helps us reduce noise and make patterns clearer, especially when scores from the NLP are extracted. The questions require us to smooth the data using bin means when bin depth equal to 3. We have to partition into bins of size of 3. So we make 4 bins of size 3. After that, we compute mean of each bin and then replace bin's mean value with the actual bin values. So for second method, for detecting outliers are extremely high impact points that skew analysis. In our list, 204 and 215 are clear outliers. If you take a look at that. Okay, so ways to detect them are box plot / IQR method. Anything above Q3 plus 1.5 into QR is an outlier, into IQR is an outlier. We can also calculate Z score, in which if we get a Z score greater than 3, it is an outlier. And clustering techniques like K-means clustering and reveal distance cluster. Here the pair of 204 and 15 forms a separate extreme cluster. These outliers represent usually serious cases in legal data sets. So some other smoothing methods apart from bin, we may apply bin medians, more robust when outliers exist, useful especially for last bin with 204 and 215. Moving averages, replace each value with the average of its neighbors, good for time series FIRs data like repeated offenses. This one. And local regression smoothing, LOESS, fits small regression across localized regions, excellent for visualizing trends and noisy complaint severity. Moving on to question 4, discuss schema integration, handling redundant entries, and resolving value conflicts. Okay, so let's take a look at that. Alright, so legal databases often duplicate entities across it, like e-file systems, physical station diaries, legacy databases. This creates redundancy, inconsistencies, and conflicting values. Two main tasks are required for them are handling redundant values. Record may refer to the same complaint even if stored in separate systems. Solution for this object identify resolution. We identify duplicates using composite keys. Okay, so composite keys example, we use date plus victim name plus police station. String similarity measures, we use Levinston distance for names, fuzzy matching for narratives. If similarity exceeds a threshold, entries are merged. So second is resolving value conflicts, in which sometimes the same complaint has conflicting values. Example, physical log says rupees 50,000, e-file says loss equal to 5,000. Ways to resolve are trust hierarchy, choose a primary source of truth. Usually e-file is more up to date. Voting strategy, when the 3 or more database disagrees, use majority rule. Conservative strategy, for legal severity, we prefer the higher value. This ensures we don't mistakenly down prioritize serious cases. So both of these questions highlight pre-processing tasks such as smoothing noisy extracted scores and integrating multiple databases while resolving conflicts. These steps ensure that downstream analytics such as severity prediction or triage operates on clean, reliable data. So thanks for watching. Hope you find it informative. We'll see you in the next one.